a planet so far away that light itself takes over 4 hours just to reach it. A world where winds scream faster than the speed of sound, where a single season lasts longer than an entire human lifetime, and where temperatures drop so low that the air itself would freeze solid around you in seconds. And here's the most shocking part. Until just a few decades ago, we had absolutely no idea what this planet actually looked like up close. Not even a single real photograph. Nothing. Just blurry dots through telescopes and a whole lot of guesswork. But then one day, a spacecraft humanity had launched years earlier finally arrived. And what it revealed changed everything we thought we knew about the outer edges of our solar system. If you have ever been curious about what lies at the very boundary of the planets we call our neighbors, hit subscribe right now because today we are going deep into the story of Neptune, the most mysterious, most violent, and most visually stunning world in our entire solar system. Stay with us until the very end, because the final discovery we share with you today is one that even seasoned scientists did not see coming. Let's begin with the basic but genuinely mind-blowing reality of where Neptune actually sits in space. When we talk about distant planets, we often throw around big numbers without really letting them land. So, let us try to actually feel this distance for a moment. Neptune sits roughly 4.5 billion kilometers away from Earth. That is 4.5 billion kilometers. If you tried to drive there in a car traveling at highway speed without stopping, not for food, not for sleep, not for anything, it would take you over 5,000 years to arrive. That is not a typo. 5,000 years of non-stop driving. To put that another way, you would have had to start your road trip before the ancient Egyptians built the pyramids, and you still would not be there yet. This is the world we are talking about. This is the place whose real face humanity did not see until 1989. Neptune is classified by scientists as an ice giant. Now, that name immediately conjures up images of a frozen ball drifting silently through space. But the reality is far stranger and far more interesting than that. The term ice giant does not mean Neptune is covered in a layer of ice the way your freezer might be coated in frost after a long winter. What it actually refers to is the chemical makeup of the planet beneath its outer layers. Neptune is composed largely of water, methane, and ammonia, but not in the solid frozen form you might imagine. These substances exist in what scientists call a supercritical state, which is a bizarre condition where the material is neither fully a liquid nor fully a gas, but exists somewhere in between, blending properties of both at the same time. It is the kind of thing that simply does not exist naturally here on Earth, and it makes Neptune one of the most chemically alien environments in our entire solar system. Only 2 planets in our solar system carry the title of ice giant. Neptune is one, and its fellow outer planet Uranus is the other. Both are fascinating worlds, but Neptune stands apart in ways that we will explore throughout this script. The sheer scale of Neptune alone is enough to humble anyone who truly sits with it. The planet's equatorial diameter clocks in at around 50,000 kilometers. For context, our entire Earth, the planet that feels enormous to us as we live on its surface, the planet that takes over 24 hours to fly across in a jet, has a diameter of just about 12,700 kilometers. That means Neptune is roughly 4 times wider than Earth. And when you look at mass, the gap becomes even more dramatic. Neptune is approximately 17 times more massive than our home planet. 17 times. If you could somehow place 17 Earths on a scale, they would just barely balance out against one Neptune. Now, here is something that surprises a lot of people when they first hear it. Despite being so massive and so far out in the solar system, Neptune actually has a shorter day than Earth does. A full day on Neptune, meaning one complete rotation of the planet on its own axis, takes only about 16 hours. Compare that to our 24-hour day, and Neptune is spinning significantly faster than we are. However, when it comes to the year, the situation flips entirely. Because Neptune orbits so far from the Sun, it has an enormous path to complete every time it goes around. one full Neptunian year. The time it takes for the planet to complete one orbit around the Sun is approximately 165 Earth years. That means if you were born on Neptune and you were trying to celebrate your first birthday by Neptunian standards, you would need to live to be 165 years old by Earth's count before that moment arrived. And seasons on Neptune are equally staggering in their length. Just like Earth, Neptune is tilted on its axis, which creates seasonal changes. But while our seasons last just a few months, each individual season on Neptune lasts for more than 40 Earth years. Imagine a winter that began before your parents were born and still has not ended by the time you're in your 40s. That is the reality of life on Neptune, at least in terms of seasonal cycles. Scientists have been able to watch Neptune long enough now to actually observe these seasonal shifts through changes in cloud patterns and atmospheric brightness, which gives them an incredible window into how the planet behaves over these long, slow cycles. The story of how humans came to know about Neptune at all is a remarkable one, and it speaks to the incredible power of mathematics and careful observation. The possibility that Neptune might exist was actually being discussed as far back as the early 17th century. Galileo Galilei, the famous Italian astronomer and scientist, appears to have actually spotted Neptune in his observations of the sky between 1612 and 1613. However, at the time, he recorded it simply as a star. He did not recognize it as a planet. For over 2 more centuries after Galileo's observations, Neptune remained officially unconfirmed. What finally brought Neptune into the official record books was not a telescope discovery in the traditional sense. It was mathematics. Astronomers studying the orbit of Uranus noticed that the planet was not moving exactly as it should based on the gravitational influence of the known planets at the time. Something was pulling on Uranus in a way that could not be explained. Multiple scientists working independently ran the calculations and predicted that there had to be another planet out there farther from the Sun whose gravity was tugging on Uranus. In 1846, Neptune was officially confirmed, its existence essentially proven on paper before astronomers even pointed a telescope at the right spot to find it. That remains one of the great triumphs of scientific prediction in human history. The name Neptune comes from Roman tradition. In the ancient stories of Rome, Neptune was the god who ruled over the seas and all the waters of the world. When early astronomers looked at the planet through their telescopes, its striking blue-green color immediately reminded them of the deep ocean, and so the name felt completely natural. It was one of those rare cases where a name just fits perfectly on multiple levels. The color, the mystery, the vast, unknowable depths that both the planet and the ocean seem to represent. That deep blue color that makes Neptune so visually stunning and so immediately recognizable is actually caused by methane in the planet's upper atmosphere. When sunlight reaches Neptune, the methane molecules in the atmosphere absorb the red portions of that light. And what gets reflected back out into space and eventually into our telescopes and cameras is primarily the blue end of the spectrum. The same process also affects Uranus, which similarly has methane in its atmosphere. However, Neptune appears distinctly more vivid and deeply blue compared to Uranus. And scientists believe this may be due to some other unidentified component in Neptune's atmosphere that enhances that blue color even further. The exact reason for this difference is still being studied today. Now, let us talk about the winds on Neptune because this is where the planet truly earns its reputation as one of the most extreme environments in the solar system. Neptune has the fastest winds ever recorded on any planet in our solar system. Wind speeds on Neptune can reach up to 2,100 kilometers per hour. To put that in human terms, the fastest winds ever recorded in a hurricane on Earth reached around 350 kilometers per hour. And those were catastrophic, devastating storms that leveled entire regions. Neptune's winds are 6 times stronger than that. They are faster than the speed of sound here on Earth. These are not gentle breezes. They are walls of atmosphere moving at a speed that is almost impossible to imagine surviving in. What makes this even more puzzling to scientists is that Neptune is so far from the Sun that it receives very little solar energy, roughly 900 times less sunlight per square meter than Earth does. Usually, the engine that drives planetary weather systems is heat from the Sun, but Neptune receives almost none of that. Yet, it has the most violent winds in the solar system. Scientists believe the answer lies in Neptune's internal heat. The planet radiates significantly more energy outward than it receives from the Sun, suggesting it has a powerful internal heat source, likely left over from the formation of the planet billions of years ago. That internal energy is believed to drive the extreme atmospheric dynamics that create those record-breaking winds. One of the most famous atmospheric features ever photographed on Neptune is a massive storm system that Voyager 2 captured when it flew past the planet. Scientists named it the Great Dark Spot, drawing an obvious comparison to Jupiter's legendary Great Red Spot. The Great Dark Spot was an enormous anticyclonic storm system, roughly the size of the entire Earth, spinning through Neptune's southern atmosphere. Wind speeds around the edges of this storm were clocked at some of the highest ever measured on the planet. When the Hubble Space Telescope turned its eye toward Neptune in the mid-1990s, however, the Great Dark Spot had completely disappeared. It had simply dissolved back into the atmosphere. More dark spots have since appeared and vanished in different parts of the planet, suggesting that these storms, while enormous, are temporary features on Neptune rather than permanent landmarks the way Jupiter's Great Red Spot has been. The temperatures on Neptune are exactly what you would expect from a world so far from the Sun, and yet simultaneously more extreme than most people realize. At the cloud tops, temperatures hover around -201 degrees Celsius. That is bitterly, catastrophically cold. It is cold enough that the atmosphere itself begins to change its behavior in ways that have no parallel in our everyday experience. However, deep within Neptune, moving down through its layers toward the core, something startling happens. The temperature rises dramatically. Near the planet's core, scientists believe temperatures may climb as high as 7,000 degrees Celsius. That is hotter than the surface of the Sun. The core itself is believed to be roughly the size of Earth, a dense rocky iron and nickel center buried beneath thousands of kilometers of superheated, superpressurized fluid. This extreme temperature gradient running on through it from the super-cold outer atmosphere to the super-hot inner core is part of what drives that internal heat engine we discussed when talking about Neptune's winds. The energy generated deep inside the planet pushes outward and fuels the chaotic, powerful weather systems that rage across the planet's outer layers. It is a system completely unlike anything we experience here on Earth, and understanding it fully remains one of the ongoing challenges for planetary scientists. Now let us get to the moment that changed everything, the first real images of Neptune. Before 1989, everything we knew about Neptune was either inferred from mathematics, gathered from distant telescope observations that showed the planet as little more than a faint, blurry disk, or simply theoretical. No human had ever seen this world in any real detail. That changed with Voyager 2. The Voyager 2 spacecraft was launched on August 20th, 1977. NASA designed it as part of a mission to take advantage of a rare planetary alignment that would allow a single spacecraft to swing past multiple outer planets using their gravity as a kind of slingshot to accelerate from one to the next. Voyager 2 visited Jupiter, Saturn, and Uranus before finally arriving in the vicinity of Neptune in August of 1989, 12 years after leaving Earth. The data and images it returned during that Neptune flyby represented the first, and to this day, only close-up visit any human-made spacecraft has ever made to Neptune. The images were breathtaking. Scientists and the public who had grown up knowing Neptune only as a faint blue point of light in the sky suddenly found themselves looking at a real world with real features. They could see the deep electric blue coloring in stunning clarity. They could see the banded structure of the atmosphere with different layers of clouds moving at different speeds. They could see the Great Dark Spot, that enormous storm system churning through the southern hemisphere. They could see smaller white clouds, which scientists nicknamed scooters, because of how quickly they moved relative to the larger atmospheric features below them. Those white clouds are believed to be made primarily of methane ice crystals, forming high in the atmosphere where temperatures drop to their lowest levels. One of the discoveries that generated enormous excitement during the Voyager 2 flyby was the confirmation and detailed imaging of Neptune's ring system. Scientists had suspected Neptune might have rings before Voyager arrived. There had been indirect evidence from Earth-based observations, but the data was inconsistent and difficult to interpret. Voyager 2 settled the question definitively. Neptune does have rings, but they are nothing like Saturn's rings. Saturn's ring system is one of the most spectacular sights in the solar system. Made up of hundreds of thousands of individual rings composed of ice and rock particles ranging from tiny dust grains to chunks the size of houses. Neptune's rings are far more subtle, far more sparse, and far darker. They are thin bands composed primarily of microscopic dust particles, and they are difficult to image even with good equipment. What makes Neptune's rings particularly interesting is that they are not uniform. They contain what are called ring arcs, which are sections of the ring where material is denser, more concentrated. These arcs were part of what caused confusion in earlier Earth-based observations, because sometimes astronomers would detect something and sometimes they would not, depending on which arc happened to be in view at the time. Scientists believe that gravitational influence of nearby small moons helps confine the material in these arcs and keep them from spreading out evenly around the planet. Understanding exactly how and why these arcs maintain their shape is still an active area of research. Voyager 2 also dramatically expanded our knowledge of Neptune's moons. Before the mission, scientists knew of only 2 moons orbiting Neptune. Voyager discovered 6 more in a single flyby, bringing the known total up over the following years to at least 14. The largest of Neptune's moons is Triton, and it deserves its own special discussion because it is one of the strangest objects in the entire solar system. Triton orbits Neptune in a direction opposite to the direction Neptune rotates. This is called a retrograde orbit, and it is extremely unusual. Most large moons in the solar system orbit in the same direction their planet spins, because they form from the same disk of material that formed the planet itself. The fact that Triton orbits in the wrong direction is a powerful clue about its origin. Scientists are convinced that Triton was not born alongside Neptune, but was instead a free-floating object from a region of the outer solar system called the Kuiper Belt, the same distant region where the dwarf planet Pluto resides, and that Neptune's gravity captured Triton long ago. If that is true, Triton's capture must have been a violent and chaotic event that dramatically disrupted the original system of moons Neptune had. Any moons that existed before Triton arrived would likely have had their orbits thrown into chaos by the gravitational disturbance caused by the new arrival. Over vast amounts of time, those original moons may have collided with each other, been ejected entirely. The current collection of smaller inner moons orbiting Neptune may actually be the result of those ancient collisions. Debris that settled into new orbits after Triton's capture reshuffled everything. Triton itself has a diameter of about 2,700 kilometers, making it the 16th largest object in the solar system by size. One comparison that helps put this in perspective is that Earth's own moon has a diameter of about 3,400 kilometers. So Triton is somewhat smaller than our moon, but still quite a substantial world in its own right. When Voyager 2 photographed Triton's surface, what it found was extraordinary. The moon is coated in a layer of frozen nitrogen. Its surface is strangely smooth in many areas, suggesting geological activity that periodically resurfaces it. And scattered across that frozen landscape are active geysers. Not volcanic geysers like the ones you might visit in places like Yellowstone, but nitrogen geysers. These geysers shoot columns of liquid nitrogen and dark dust high up into Triton's thin atmosphere, where it then drifts downwind and falls back to the surface, leaving dark streaks across the frozen ground that are visible in the Voyager images. The energy that powers these geysers appears to come from sunlight. Even the weak, distant sunlight that reaches Triton being absorbed by the dark materials beneath the surface nitrogen ice and converted into heat that then vaporizes the nitrogen from below, driving the geyser eruptions. Triton is also significant for another reason. Because of its retrograde orbit and the way it is slowly spiraling inward toward Neptune due to tidal forces, scientists have calculated that in roughly 3.5 billion years, Triton will get close enough to Neptune that the gravitational tidal forces will tear the Moon apart completely. The material that once made up Triton would then form a new ring system around Neptune, potentially one far more spectacular than the current sparse rings. It will not happen anytime soon in human terms, but on the time scale of the solar system, it is a known inevitable fate already written into the mathematics of their orbits. The moon discovered most recently in Neptune's system is called Hippocamp. It was found in 2013 using images from the Hubble Space Telescope, and it holds the distinction of being the smallest known moon of Neptune. Hippocamp was not visible to Voyager 2 during its 1989 flyby, partly because of the limitations of the equipment available at the time, and partly because of how small and dark the moon is. Its discovery is a great example of how Earth-based and space-based telescopes have continued to add to our knowledge of the Neptunian system even decades after Voyager passed by. Other moons in Neptune's system include Nereid, which was discovered back in 1949 by the astronomer Gerard Peter Kuiper, the same scientist whose name is now given to the Kuiper Belt. Nereid holds a notable distinction as having one of the most eccentric orbits of any moon in the solar system. Its path around Neptune is highly elliptical rather than circular, which again hints at a past event that dramatically disturbed the orbits of objects in the Neptunian system, likely connected to that same ancient capture of a Triton that reshuffled everything. Then there's Proteus, one of the moons discovered by Voyager 2. What makes Proteus immediately fascinating when you look at images of it is its shape. It is not round. Most substantial moons in the solar system are round because their gravity is strong enough to pull their material into a spherical shape over time, but Proteus is irregular, lumpy, and battered looking, almost like a dark, rocky potato drifting through space. It is one of the darkest objects in the entire solar system, reflecting almost no light at all. Before Voyager 2 arrived, humanity had no idea this moon even existed. It is worth taking a moment here to reflect on something genuinely amazing about the continuing mission of Voyager 2. The spacecraft, launched in August 1977, flew past Neptune in 1989 and has now been traveling through space for nearly half a century. It is still out there. It has crossed beyond the heliopause, the boundary where the sun's influence on the surrounding space fades and interstellar space truly begins, making Voyager 2 one of only two human-made objects to have entered interstellar space. It still communicates with scientists back on Earth, sending back data about the environment at the very edge of our solar system and beyond. The signals it sends back now take over 17 hours to travel at the speed of light from Voyager's current position back to Earth. Every piece of data it returns is a gift from an era of exploration that began decades ago and is still paying dividends today. For all that Voyager 2 revealed, Neptune still holds enormous mysteries. We have visited exactly once with exactly one spacecraft for a relatively brief flyby. There is so much we still do not know. We do not have detailed maps of all its moons. We do not fully understand the internal dynamics that drive its extreme weather. We do not know precisely why its winds are so powerful. We do not fully understand the ring arcs or how they maintain their concentrated structure over time. And there may well be additional small moons orbiting Neptune that we have not yet detected hiding in the darkness far from the Sun. Scientists have proposed future missions to Neptune and Uranus, recognizing that the ice giants are actually the least explored class of planet in our solar system, despite being among the most common types of planets found around other stars beyond our solar system. Understanding ice giants is not just about satisfying curiosity about our own planetary neighborhood. It has implications for understanding planets throughout the galaxy. Proposals for a dedicated Neptune orbiter, a spacecraft that would not just fly past but actually enter orbit and study the planet and its moons in detail over years, have been circulating in the scientific community. Such a mission would take decades to plan, build, and travel to Neptune. But the scientific return would be transformative. The images that Voyager 2 captured, later supplemented by images from the Hubble Space Telescope and other modern instruments, gave us our first real view of one of the most remote and remarkable worlds in our solar system. What those images showed was not a quiet, dark, frozen place sitting passively at the edge of our planetary neighborhood. Neptune is alive with movement, with storms, with winds of incomprehensible power, with moons that have active geology, with rings that arc and concentrate in ways science is still working to explain. It is a world of constant, violent, extraordinary activity, happening in near total darkness, billions of kilometers from the warmth of the sun. Every time we expand our vision outward into the solar system, we are reminded of how much is out there that defies expectation. Neptune is a world that looks peaceful in photographs. That gorgeous, deep, tranquil blue immediately reminds you of Earth's oceans, just as the ancient Romans felt when they chose the name of their god of the sea. But beneath that serene appearance is one of the most turbulent, powerful, and extreme environments in our entire solar system. It is a world of supercritical fluids and supersonic winds, of ancient captured moons and dark mysterious rings, of temperatures that span from impossibly cold to almost unimaginably hot, all within the same planet. What Voyager 2 gave us in 1989 was not the end of the story. It was the very first chapter of a story we have only just begun to read. The real images of Neptune were the first words on the first page, and everything they revealed has only deepened our understanding of just how extraordinary, how complex, and how endlessly surprising our solar system truly is. The outer solar system is not empty space. It is a frontier filled with worlds waiting to be understood, and Neptune stands as one of the most breathtaking of them all. That is the full story of the first real images of Neptune and what they revealed to us. If you found this fascinating, share this with someone who loves space. Drop in the comments the one fact from today that surprised you the most, and subscribe if you want to keep exploring the universe together. There is so much more out there waiting for us. There is one more dimension of Neptune's story that deserves to be told, and it is perhaps the most humbling of all, the fact that Neptune cannot be seen with the naked eye from Earth. Of all the planets in our solar system, Neptune is the only one that is completely invisible to a person standing outside on a clear night simply looking up at the sky. Every other planet, Mercury, Venus, Mars, Jupiter, Saturn, even distant Uranus, can under the right conditions be spotted without a telescope. Neptune cannot. It is too far, too dim, too small in the sky. You need a telescope just to see it as a tiny bluish dot. And yet this invisible, unreachable world is orbiting the same star as us, traveling its slow 265-year path around the Sun in the same solar system where our own small blue planet spins and breathes and teems with life. That invisibility has always been part of what makes Neptune so psychologically compelling. The other planets, our ancient ancestors could look up and watch them move against the background of stars. They named them after their gods and built entire belief systems around their movements.